Welcome, everyone. It's a great pleasure for me to introduce our speaker, Dr. Olga Komisarova. Our speaker is a recent PhD graduate from Seton Hall University College of Education and Human Services. Olga, right now is working as a researcher for World Education Services, WES, and she has a great depth of experience in business data analytics. Today, we are here to listen to her talk on the growing interest in unstructured data for business intelligence. Unstructured data include everything from documents to images to videos to audio streams, even social media posts. All these type of data account for about 90% or more for overall digital data universe. Since we all here for the love of data, we are so excited to learn more from Olga about unstructured data. Please join me to welcome Olga.
Thank you. Thank you so much, Sema. I'm really happy to be here. I hope you're enjoying this romantic data week. And I remember when I was a student at Seton Hall, I used to enjoy Lab Data Week sessions. They were always very invigorating, and they actually encouraged me to start a career in data analytics. And today I would like to share some of my experience. So let me go ahead and share my screen. Can you see my screen?
Yes, we can.
Wonderful. Second. All right. Today, I will be talking about data lakes and unstructured data. I'm not sure how to turn off these captions. Do you see these captions here?
Yes, I can see the captions.
Is this okay, or we should try to?
Let me see if I can turn them off.
Oh, I kind of like them. Okay.
Oh, okay.
Yeah.
Great.
So keep them, or?
I think we're going to keep them.
Okay, let's keep the captions. Wonderful. So this is our plan for the session. I will start with a brief introduction of my experience with data and sharing my motivation for this presentation. Next, I will introduce the concept of data lakes and will tell you why companies are interested in building data lakes. Then I will talk about unstructured data and how companies use insight from this type of data. And lastly, I will present a use case of how unstructured data can be analyzed. And I will finish with some Q&A time. I hope this sounds good and we can proceed. This is my introduction. My data journey started at Seton Hall University, where I worked as a graduate assistant, and my primary responsibility was to assist professors in the Department of Educational Leadership with their quantitative research projects, which were related to education, finance, and policy. During summer after graduation, I had a chance to work as an instructional aide for Inter-University Consortium for Political and Social Research. If I am not mistaken, that was ICPSR that first created and promoted Lab Data Week, but I'm not sure. Sema, can you confirm that?
Yes, you're right.
Yes. So ICPSR is greatly involved in the promotion of love for data. And after ICPSR, I got data analytics experience at our tech startup in New York City. My primary responsibility was to build reports on product analytics. And just 4 months ago, I got a new job as a senior data analytics associate in growth, innovation, and strategy team at World Education Services. Abbreviation is WES. It's a nonprofit organization that supports immigrants in the United States and Canada. This organization likes to call itself self-sustainable social enterprise. And I'm working on different business research projects that inform strategic decision-making. This is my data story. And now let's move further. What was my motivation behind this presentation? First of all, Love Data Week is about sharing experiences with data, and I want to share some of my experience in the world of data analytics. I also want to provide some high-level insights into two trends in business data analytics, which are, as you know already, data lakes and unstructured data. And my goal was to make this presentation comprehensible for people with different backgrounds, and I'm not going into highly technical details of these concepts. And finally, I really hope to spark your curiosity and encourage you to dive deep into the world of data analytics. I want to encourage you to grow your data analytics knowledge and skills, because this is very important in today's world. Now let's proceed with the introduction of data lakes. When I started working as a data analyst, I learned that organizations that I work for perform business analytics using data lakes. And generally speaking, data lake is a unified repository location for storage of all sorts of data that is relevant for an organization. To better understand data lakes, let's look at data analytics cycle. This is an illustration of a typical cycle that has 4 stages. The first stage of the cycle is data ingestion. Data is streaming into the lake from various sources. This can be internal or external sources. And data comes in a raw format, which means that it can be structured or unstructured or semi-structured. And I'll be talking more about unstructured data a little bit later in the second part of the presentation. Now, the second stage, it's data storage. Thanks to cloud computing technology, there are absolutely no limitations to amounts of data that can be stored in a data lake. Cloud service providers ensure that data is secured, protected, and at the same time, it's also important to know that data lakes do not have to be situated in clouds. Some organizations prefer to locate their data lakes on their own servers. However, from what I've seen, organizations tend to go with cloud storage because it significantly reduces costs. Plus, cloud service providers guarantee data protection and security. The third stage of the cycle is data processing. It is also called data curation. That is when data gets categorized. That is where data can get some structure. After this operation, the data can be pushed back to the lake for further storage, or it can be used by business intelligence. And then the fourth stage, the final stage of the cycle, is data consumption. And not every data goes through this stage. In the illustration, you see that it is described as connecting data with analytics and machine learning tools. On this stage, end users can use organizational data for reporting or predictions. Data lake gets connected to data analytics tools such as Tableau or Power BI. And what is great about data lakes is that they support so-called native streaming. Native streaming means that the stream of data can be processed and available for analytics and reports and predictions as soon as they arrive into the lake. And this is very important in today's dynamic business environment. And from this illustration, you can see that data lakes are an integral part of business analytics cycle. And of course, not every company has a data lake or plans to build one. This is typically a story for larger companies, for enterprises, corporations. And if a company wants to ensure competitive advantage and growth, there is a big chance that it will want to build its data lake. Now, another way to look at data lakes is by comparing them with their predecessor, which is their data warehouses. Back in the days, most organizations used to have data warehouses in place, and data warehouses are highly structured relational databases. A high level of structure is needed to support SQL operations, and I'm sure you've heard of SQL, which stands for Structured Query Language. And now let's look at comparison of these two types of storage. The first difference, and this might be the most important difference, is the requirement for data type and structure. Data warehouses require data to be cleaned and transformed and well organized before it can be ingested. Another difference is that data is not loaded to the data warehouse until there is a clearly defined use for the data. While at the same time, if you have a data lake, you don't need to know what would be the best use for the collected data, but you would still keep it until you decide how you're going to use it. Data lakes easily adapt to change, while for warehouses, a lot of time needs to be spent upfront during development to get structure right. And once the structure is established, it will be very difficult to change it. And finally, the pricing will be different. It's much more cost effective to deploy a data lake because data lakes are typically built on highly scalable, low-cost servers, and they're more likely to be cloud-based. On the other hand, data warehouses are more expensive because in addition to storage cost, you will also need to pay computational costs for running analytical queries. That's just how data warehouses are set up. So the previous slides already outlined the benefits of data lakes for organizations. It's important to remember, as Sema said, that 90% of organizational data is unstructured. And with Data Lake, we can add that unstructured data and create some more meaningful business analytics. And with data lakes, we can use much more data for decision making. As I mentioned previously, data lakes are scalable and flexible. They can be easily expanded and modified based on organizational needs. They are also affordable. And the last thing that I would like to add is that data lakes help prevent data silo. Data silo often happens in big organizations when only one department or business unit has access to some data. And when there is a data lake, all information is gathered together, information and data from different units. In my current organization, we've built a data lake that combines data inputs from almost every business unit. And now we're looking into expanding the lake to add more customer-related data from the outside of the organization. And these are three biggest data lake platforms that are typically used by companies. You see there are reputable and trustworthy names: Microsoft Azure, Amazon Web Services, Google Cloud. Companies that I worked for have their data lakes based on these platforms. And it is also worth noting that some organizations prefer to have multiple data lakes based on different platforms. And this is what I wanted to share about data lakes. Now, let's move on to unstructured data. Unstructured data, generally speaking, is information that is not arranged according to a preset data model or schema, and therefore it cannot be stored in a traditional relational database. And as Sam already noted, there are so many different types of unstructured data, and it can be human generated or machine generated. Among the kinds of human generated data are text files, emails, social media data. Some examples of machine generated data are sensor data, which are data from traffic or weather sensors, or media files, photo, video, or audio, video surveillance files. And there are some key differences between structured and unstructured data. Structured data will most likely contain numbers or objective facts, a person's email address, for example. Unstructured data will most likely be made up of objective textual messages. Structured data is clean and accurate, and it is fairly easy to perform analysis on structured data. And there is a variety of tools available to do that. Unstructured data can be stored in a variety of formats that are easily modified based on business needs. And this data can have great insights that could amplify competitiveness of a company. And of course, there are some disadvantages in unstructured data. Primarily, is that it's very difficult to prepare and analyze unstructured data. You would need a team of data scientists to understand the data and to draw value from it. And the second disadvantage is that it requires a very specific data tool. And organizations are now looking for specific data management tools that would satisfy their business needs. And I will show you one of such tools in just a couple minutes. So why organizations show interest in unstructured data? From my professional experience, I can tell you that companies are increasingly interested in unstructured data. I am currently working on 2 projects that intend to use unstructured data. The first reason for the interest is that organizations sense that unstructured data can help them become competitive. There is hope that unstructured data will help to understand unique needs of customers. There is also a rapid growth in digital communication technologies that ensures easy access to a lot of data. And additionally, the development of cloud computing provides opportunities to store and process big volumes of data. And finally, more and more tools are being developed. And new tools are becoming more sophisticated in analytics techniques, and they also become more user-friendly. And I would like to show you one of those tools. The use case is about a software that can generate insights from unstructured textual data like tweets, Facebook posts, reviews, comments, news articles. And in this example, I will be using recent Twitter data. On Sunday, I uploaded 1,800 tweets that contained one keyword. The keyword I chose was Olympics, because Winter Olympics is something that many people are talking about right now. So let me show you the data that was uploaded. Can you still hear me and see the screen?
Yes.
Yes.
Awesome. So this is a CSV file that contains Twitter messages that have Olympics, a keyword. Then I went to this software tool, which is based online, and added this data into the system. And the software tool supports both CSV and JSON files with textual data. Here you see a dashboard. In our scenario, we have 1,100 tweets And the software, what it does, it aggregates all these tweets based on features or similarities, and it is generated by machine learning algorithms. Then all these tweets were put into buckets. So through this analysis, 10 buckets were created. They're called stories. So the major topics related to Olympics are listed here on the right side. So instead of going through the entire data of 1,800 tweets, one can simply go through the list of stories. You see the 10 stories, and it's easy to get understanding of their entire data set of tweets. And another feature that this software has is it uses entity recognition to identify and categorize key information. This particular software supports the following entities: people, trending organizations, you can see here, and trending groups, which can be nationality, religion, or political group. And with such analytic tool, organization can get insights from the ocean of data that is available today in the internet. And with this, I would like to see if you have any questions or comments. I see Elizabeth, raise your hand.
Hi, well, thank you so much. I had never heard of data lakes before, and so I'm very excited. It's really good for me to keep, as a business professor, it's good for me to keep up with these things. So thank you so much for sharing all of that. The question I had was, you downloaded that information from the tweets.
Mm-hmm.
But
Right.
what if you have an existing database of, say, interview data? Is that also kind of, can you do that a similar kind of analysis with that software?
Yeah, absolutely. The software, you can upload interviews, and it can divide it into themes, and it can use entity recognition to provide some insights. And also, this is not the only software that exists today. There are so many that are existing already, and so many are being developed very rapidly.
Yeah, because when I did my dissertation, I used Atlas TI, I think it was called, and it was not very sophisticated and did not have much, like there was no machine learning embedded in it. And so that's why I'm really curious about, with tweet data, it is kind of assumed, I guess, that you're going to be tweeting about a person or an event or an organization. While the interview data is much more, I was interviewing them about business strategy and things like that. So the machine learning would be able to handle that, huh?
Yes. And the further we go, the more sophisticated the analysis will get. And I'm curious, how did you end up presenting your, what methodology did you use in the end? Did you still go with Atlas TI?
Actually, I ended up making Excel spreadsheets. I did it all manually. This was a long time ago, of course. But yeah, so there was no machine learning whatsoever. Just used Excel to organize the data and the coded data. It was very laborious, and I would not recommend it.
Well, hopefully there are solutions now for people who work on research projects.
Good.
Thank you
very much.
Thank you, Elizabeth. And I see 2 raised hands. I see Sema has a question.
Yes, thank you so much for this great presentation. I learned so many. I have like a couple questions. So with the software, the number of topic, can you reclassify them if you decide, like how flexible is it if you decided not to go with the first 10 set and you want it more, can you change the algorithm, or it's just like preset for you?
At this time, it is preset, and the number of stories, topics, groups it will grow if you add. It typically grows, from what I noticed, it grows if you add more data. Like if we had instead of 1,800, if you had 100,000, it will be a significantly larger amount of groups.
Amazing. Thank you so much.
Thank you. I see John John has a question.
Hi, yes, thanks. Very interesting topic. I was wondering, how do you marry the unstructured data with structured data?
In
like now that you have this you did the analysis on the tweets, and let's say there's you do it for products, and you have like structured data about the products, like revenue or what have you. How do you marry this unstructured data that you've just done an analysis on to sort of more traditional structured data to expand the analysis?
Sure. Well, there is a lot of possibilities, but one that pops up in my head right now is if you use, let's say, this Twitter data, and you collect Twitter data for different periods of time. Like right now in this data, I only collected data that from tweets that went out on Sunday. But if you collect data from prolonged periods of time, let's say you collect data for every month and do the processing, and the insights will be, the groupings, the analysis will be different for every month, I would expect. And then you go and look at your structured business data that is available, and time series data, and you compare how existing structured data, the variables, can affect, if there is any correlation between analysis, the output that was received from after the unstructured data analysis tool with the structured business data available.
Got it. Yeah, right. That's sort of what I was thinking. Would you do that in Excel, or is there could you do that more in a database structure?
It's well, the companies usually do this in let's say in my company that I worked for, product development analytics that I worked for, we use Databricks.
Got it. Thank you.
Thank you.